All right, today we're going to continue to talk about triangle congruence, and the postulate that we didn't get to yesterday is called side angle side. Side angle side postulate. Side angle side postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Side angle side. If the side, included angle, and side, see it? Side, included angle, and side of one triangle are congruent to the side, included angle, and side of another triangle, then the triangles are congruent. Now, here's what that would look like. If you have triangle ABC and triangle DEF, here is a side, an included angle, and a side congruent to a side, included angle, and a side. This term is very important. This included angle. When you're using side angle side to determine triangle congruence, do you see how this angle is touching both the congruent sides? And this angle E is touching both of these congruent sides? That's what included angle means. All right, the included angle is formed by the congruent sides. Very important. Now, we know these two triangles are congruent by side angle side. So we're going to write a congruent statement. When you write your congruent statement, you can call the triangle, you can call your first triangle, you can describe your first triangle, and order the vertices any way you like. Okay? So we're going to call this first triangle, I'm going to call it ACB. And we're going to say that triangle ACB is congruent to triangle. If we called the first one ACB, what do we got to call the second one? A little louder? DEF, very good. Got to call a second one DEF. When I'm describing, or when you're describing a triangle, I always look at it as the first vertex is where you're starting and you're going a direction. So if I call this ACB, I'm starting at A, I'm going to C, and then I'm ending at B. Does that make sense? I went counterclockwise. It doesn't matter counterclockwise or clockwise. But I started at A and I went through the side that had one tick mark on it. So I have to, when I label this or when I describe this second triangle, I have to go through the side that has one tick mark on it. And if I went from a non-congruent angle to the congruent angle, I have to go D to E. So that's what makes me go D to E. Started at D, went through the side with one tick mark to the congruent angle. And then I went from point C through the side that has two tick marks. So from point E, I have to go through the side that has the two tick marks. So that's what a picture of two triangles that are congruent by side angle side would look like with tick marks and arc marks. Now you could also be given those same two pictures, and instead of tick marks, you could be given values. Agreed? Another way of looking at this would be if this was ABC and DEF, and if AC was 8 and this angle was 60 and CB was 12, and these two triangles are congruent, what's the measure of DE? If these two triangles are congruent by this congruence statement, what's the length of DE? 8. What's the angle of E? The angle measure of E, I'm sorry. Good. And side EF. It's got to be 12, doesn't it? So whether you're given tick marks and arc marks or you're given values, those two triangles are congruent by by side angle side. Okay. I think right now, you're going to be better off just watching and not writing for a second. Okay? Watch, don't write. Yesterday we talked about side congruence. Today we've talked about side angle side congruence. Agreed? All right. I'm going to give you two triangles right here. Are these two triangles congruent? If so, which postulate proves their congruence? Are they congruent? Yes. Why? By what rule? What do the tick marks tell us about the two triangles? the tick marks don't say I'm congruent, do they? Do the tick marks say that 3 sides of one triangle are congruent to 3 sides of another triangle? Okay, so the triangles are congruent. What are they congruent by? What's the reason they're congruent? By what? What's this theorem called? What does the SSS stand for? Side, side, side. So you would say yes by side, side, side congruence. See how you answer that question? Not with just a yeah, they got tick marks. Yes, they're congruent by side, side, side congruence. You have to give the reason. You got to be a little more descriptive. Okay? What about these two? Are those two congruent to each other? No. Why not? A little louder. You said they're not. No. Why not? All the sides aren't the same, are they? Okay? All the sides aren't the same. And maybe if that was an AB and this was a B, not a BC, but a DE, you would say that DE is not congruent to AB. See the difference in the two? All right. What about these two? Oops. Are those two triangles congruent to each other? We're going to make sure this one actually closes. Are those two triangles congruent? I got you. Some say yes, some say no. Why aren't they? Yeah. The arc mark or the included angle? Where should the included angle be? Angle B, right? Look, it has to go side, included angle, and a side. You see how this one went side, angle, uh-oh. These are not congruent. This is no. They're not congruent. All the 3 sides aren't the same. And the included angle is not congruent. All right? The included angle is not congruent. If this was angle A, you would say no. Included angle is not congruent. Here and here. For these two triangles to be congruent by side, angle, side, where does the arc mark have to go? Where? Angle D. Agreed? Arc mark's got to go right there for side, angle, side, doesn't it? All right, so are they congruent? Good. Say yes. By what? By side, angle, side congruence. Clearer? You have to be able to see side, angle, side congruence, or see that two triangles are not congruent by side, angle, side. All right, it's got to be a side, included angle on a side, congruent to a side, included angle on the side. All right, so let's talk about two more postulates. Angle, side angle congruence. Angle, side angle congruence. Here's the rule. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle then the triangles are congruent. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. It would look like this. Angle, included side, and angle. Congruent to an angle, included side, and angle. The included side it touches both the angles, doesn't it? The included side has to touch both the angles, both of the congruent angles. There's your included side. It touches the congruent angles. Congruent statement. Triangle ABC is congruent to triangle. We went triangle ABC. What do we got to call the second triangle? YZX. Very good. We started with the angle with one arc mark, angle A. We went down the side with no arc, with no tick marks. So we went AB. So we have to start at the vertex or angle with one arc mark. And we have to go down the side with no tick marks. So we had to go this way. And then there's only one place left to go. That's to the third vertex. And angle A corresponds to angle Y. Angle C corresponds to angle X. and everything is in alignment. The congruent side has to touch the two congruent angles. The congruent side has to touch the two congruent angles. Angle side congruence. Angle side congruence. Now, do you see how it's angle side? All right, so the theorem says that if two angles and the non-included side of one triangle are congruent, to two angles and the non-included side of another triangle, then the triangles are congruent. If two angles in the non-included side of one triangle are congruent to two angles in the non-included side of another triangle, then the triangles are congruent. So draw your two triangles again. We'll label them BMO, TSR, and we're going to go two angles and non-included side. Two angles and a non-included side. So we go angle, side. The side now is not touching both of the angles. Angle, side, congruent to angle, non-included side. There's your picture. Congruent statement would be that triangle BMO is congruent to triangle BMO. What's it congruent to? Triangle who? SRT. By angle, side congruence. Questions? I'm going to draw two triangles. I'm going to mark them up. You're going to tell me if they're congruent. Are those two triangles congruent? No. Don't we got angle side angle going on the left? And on the right we got angle angle side? They're not congruent, are they? Okay, very good. Very good. So you can see what they should look like and what they shouldn't look like. All right, anybody got any questions on any of that from today? Pretty fascinating stuff, huh? Yeah, I thought so too. Here's your practice for today, page 280. Page 280, 14 and 15. Page 282. A lot of the stuff on page 282 is review. It's almost all review. 27 through 34. And you are going to, upon completion, and when you have your notes in front of you and all these problems done, you're going to check focus for homework. I need everybody to listen. Everybody that's in here and everybody that's supposed to be e-learning needs to listen, okay? Because I'm getting a lot of emails about people or from people that are asking questions about things that have been gone over multiple times in class, okay? So whether you're in class or you're e-learning, or you're an in-class student but you're absent, you're responsible for all the work. You're responsible to get the notes in your notebook, to get the assignment complete in a timely manner, and to check focus and do the electronic assignments, and to take your quiz in a timely manner and get your answers uploaded to focus. I got an email today from someone who today was taking quiz 5. Quiz 5 was on Friday. Whether you were in school or not in school, quiz 5 should have been taken on Friday and uploaded, submitted, done. Not on Tuesday, 3.5 days later. That's not a timely manner. And if you couldn't do it on Friday, then you should have done it on Saturday. And if you couldn't do it on Friday or Saturday because you were that sick that you couldn't sit down in front of a computer to take your quiz, then you should have done it on Sunday. The assignments, do them when they are assigned, not when it's convenient for you. I'm getting way too many of those emails. I am clamping down on deadlines. I leave homework assignments open on focus for a week. And people are still asking to turn in late work. And the answer is no. And if your parents have a question about that, be sure to tell them the answer is no. That I had a week to do the assignment and submit it, and I didn't. Everybody completely understand me on this. All right, that's a nod of the heads, I hope. I hope you're listening at home. Because I got to say, it's getting old. This is a pre-ACE class. You're supposed to be on the track to be taking ACE classes, which means you're going to get an ACE Cambridge diploma. Late work is not accepted. Do what you're supposed to do on time and get it submitted on time. Okay? I love it when someone that's been sitting in class is all of a sudden not in class, but then all their work is turned in a very timely manner. Okay? That means they've been paying attention and they're doing what they're supposed to be doing, whether they're sitting in the class or they're sitting at home. And that's the way it should happen. Doesn't matter if you're here or not. You can get all the notes, you can get all the information, you should be doing all the work on time and submitting all your work before it's due. I hope I've made myself very clear on this matter. You guys that are at home, you're excused to go do the assignment today, now. And then check focus sometime later today for an electronic homework assignment. You all are excused, and I'm going to end this meeting.